Okay, welcome everyone. We are very pleased that we can present our ideas about point cloud, visualization, analysis, and the use. And we do that together.
Sorry?
We do it together. So
We do it together. Yes, we do it together. My name is Martijn Meijers. I work at Delft University. And you are?
Okay, sorry, I had to announce myself, but we'll do it again. Verbree, also at Delft University of Technology. Okay, there we are. Martijn, I would like to ask you the question.
The question.
The question is the main question. Why are we here in this course, in this MOOC, and why do we put that much focus on point cloud data?
Why so much focus on point clouds? I think point clouds are really the source of information of the future. And these point clouds are really a rich source of information because point clouds are collected these days, for example, from images, but also from laser scanning. There's a lot of attributes that you can attach to these points. Huge amounts of points, quite close to the objects in reality. Much richer than what we currently see in most of the models that we're using for planning new cities, planning new buildings, in which we basically process this information and throw away a lot of details.
Yeah. What you say, you throw away a lot of details, and that is maybe something to avoid. But what you also should know is that till today you have to rely on other means or other resources to get that kind of point cloud data, and these are now available. But you don't have to forget that, or it is very important to state that we think that in the upcoming future there will be a lot of, for example, self-driving cars. Most people call these things cars. We call them collecting devices because they collect by all kinds of sensors, in most cases a lot of point cloud data. All kinds of X, Y, and Z coordinates with attributes, with intensity, whatever, from the environment. And if you can get to these sources, and it is very easy to do so, then you can have, or you will get, a one-to-one representation of the reality as is. And that is a very, very good data source.
So really a high definition 3D model as is representation of the world.
Yeah, and high definition and very, very current. It is being collected, or it will be collected today, yesterday, a couple of days before, but it is the situation as is.
Cool.
Okay.
So Edward, we discussed that point clouds are very rich, but what do you actually have against these current 3D models?
Yeah, it is not that I really against it, but it's a very limited approach. I will try to explain it to you.
Okay.
Because in most cases we use the term level of detail, and that level of detail assumes that you can get a kind of a model of all kind of city-related objects at a specific different level of detail for all kind of needs.
Okay.
And I'm also really not against that approach, and we have colleagues doing that the same alike. We have done it also. But what you will see is that in that approach, in most cases, people will take up current 2D registration, either from a roof set 2D representation or the ground level geometry.
Okay.
And then they take with that a very rich, smart point cloud data set. And what they only then do is to try to get one representative height value of that building.
That sounds like a difficult task.
It is, because you have to combine a lot with it. You really have to combine a lot with each other. A lot of points which are more or less inside that 2D geometry. But in the final situation, you only get a kind of a building block.
Okay.
And then you have to realize that both the input data, the 2D geometries, is not really a kind of a geometry, but it's only a kind of a placeholder. It is.
Okay.
It represents that there is a building there, but it's really not the actual outline. It's a kind of a generalization of that outline.
Because those building blocks, they will not contain windows, they will not contain doors.
Yeah, it's not only about the building blocks which you are going to create, but also again the input data. Because if you use a 2D outline geometry,
okay,
it is only the outline of a building.
Yeah, understand.
It is really not the building in itself. And then you are going to combine it with the height data and you will get a kind of a 3D building block. By doing that, it is also, you have to realize that one value, one height value for one building is really not like it is. There are hardly buildings built in our environment with one height. We are here at the Faculty of Architecture and we are a lot of colleagues designing buildings, and they design buildings that are really very, very, very complex. And the more complex they are, the more difficult it will be to get a proper representation of the buildings.
Just with blocks?
Just with blocks, or even with more shapes.
Okay.
That's one. And the second issue is that I think we have forgotten that we are there to feed the needs of others. These geometries, these 3D geometries, these 3D models are being built for a certain application.
Okay, so if your application is different, then you cannot use the model maybe,
or
you would need more details.
Yeah, because we are not there to know each and any application.
Okay.
And if you don't know that, then it's really very difficult to get there.
So rather stay to the source.
Yeah,
with all the rich information that is already there.
Yeah.
Instead of creating models which probably have their place, but better to stay with these rich sources.
Yeah, that is, I think, the bottom line. Thank you, Martijn.
Okay. So directly using point clouds, that would also mean that you can directly analyze your point clouds, right? And load your point clouds in a system that you already have for processing geographic information.
Yeah. I think you ask yourself, okay, if you are that convinced about point clouds, and that point cloud handling is that easy, and if you can really query the data as is, then
all the rich information, directly use it in the analysis. So collect the point cloud, put it into your GIS, and push a button. Now I want to compute this or that.
Yeah, I think that's possible, but we should put some effort in doing so. Because I have to confess that if you now go to the current GIS systems, you can look forever to the button where is the point cloud processing tool.
Okay. It's not there.
No, it's not there. There are a lot of tools there are a lot of tools to process point cloud data to other kind of representations, like voxels, maybe derived rasters or whatever. But there is no fuse set analysis yet based on point clouds. There is no volume calculation or a surface calculation on point clouds.
Okay, wouldn't you be able to do that right away with your points? If these points are very dense on your model?
Yeah, the first of all, you have to ask yourself, is it really needed to do that kind of analysis?
Okay.
Because if we are human beings and if we just look at the data, we can do the processing ourselves. Because the data
Okay.
database says it almost gives you the answer. And secondly, these tools have to be developed.
Okay.
And that
In an
is
interactive
maybe
fashion, you mean?
in an interactive fashion, but also that there is some possibility to do this kind of direct analysis on point clouds. That should be there, it should be available, it should be developed, it should be up and running in GIS packages which are not being used by researchers but by in everyday life, at municipalities, governmental organizations.
Okay, so you basically say if we want to do this, then we should make tools available that directly use the points, make it possible to perform direct visualization of the analyzed results. Because these point clouds are so dense, we can also get results by just looking at these point clouds.
Yeah.
And tools, statistical tools, making intersections, making height profiles, these kind of things, would enable you to get insights in an interactive fashion with these kind of tools, right?
Yeah, exactly. I think that's a very good resume of what I try to tell you.
Okay, well, sounds interesting.
It is very interesting, but we only have to convince others, and we are doing that.
Okay, let's use point clouds directly.
In an interactive way for explorative use.
Okay.
Okay, thank you. See you next time.